Hello, and welcome to the Integration Workshop 3, Group 5 Idea. The problem: ensuring security in shopping malls, particularly during the night, demands constant and effective surveillance. However, security teams often face resource limitations, making it challenging to cover large areas and detect suspicious activities such as movements, noises, and the presence of smoke. Additionally, maintaining the accuracy and reliability of security patrols is a significant challenge. So our solution is a security robot that helps to monitor the shopping mall security. Operational definition. The robot's operation is simple. The first stage is configuration. When it's turned on for the first time, the user must install the application on his cell phone, and to connect to the robot, the QR code embedded in it are read. The user and the robot need to be connected to an Wi-Fi, not necessarily to the same though. After logging in, the user can see the robot's battery status and access its camera. The user can also set up a route, but we'll talk about it later. Once the recording is complete, the user can put the robot in surveillance mode by going to the Configure Routes section in the app, selecting the desired route, positioning the robot on one of the Aruco markers on the route, and pressing the Start button in the app. At this point, the robot will start repeating the route in a circular pattern, detecting movement, smoke, and noises. If anything unusual is detected, the robot's audible alarm will activate and an alert will be sent to the cell phone to which the robot is linked. The route cycle works in such a way that you can select the amount of time the robot will spend taking the route. Always bearing in mind that the robot has the autonomy to work for 8 hours straight before needing to be recharged. If the response time between scans is much longer than stipulated during routing, a notification will be sent to the application alerting about potential obstacles. To ensure the necessary precision, each time the robot encounters an Aruco marker, it will position itself at a fixed distance from the marker that will be calculated using the size of the marker read and processed by the camera. This will happen every time an Aruco marker is read in both the configuration and surveillance phases. As were mentioned before, robot will have two wheels with motors and motion encoders, and its primary goal is to patrol a predefined circuit within an indoor shopping mall environment. It will be responsible for identifying any suspicious or unexpected movements along its route, as well as detecting potential fire hazards using smoke and flammable gas sensor and noise detection. The key components of its operation are as follows. Marker placement. Initially, Aruco markers will be placed on vertical surfaces within the robot's intended path horizontally aligned with the environment's ground. These markers will be positioned with its center being at height from 50 centimeters above the ground, with 50 centimeters also being the height of the robot's camera. All markers must be at the same height, and the maximum distance between different markers or consecutive markers should not exceed 10 meters. Setting the starting point. The user will position the robot at a location with a visible Aruco marker for the camera to identify as the starting point of its route. Using a mobile application that communicates with the robot, the user will initiate the route recording process. Instantly after the start, the robot will search for the first Aruco marker within its field of view to establish the starting point of the route. During the route recording process, when the user chooses to read a marker, the application will display a successful marker reading message, allowing the user to proceed to the next marker in the route. The Aruco marker reading will be done using programming language Python and OpenCV to do the computational graphics processing. The recording of the route between markers will work as follows. It starts from the last successfully identified marker. As the robot moves between markers, it will store information about the rotations performed by its motors and the rotation of its movement, using data from encoders and a compass module. When the robot approaches the next marker, the user indicates that a marker reading should be performed. If the robot is not at an appropriate distance or alignment for marker reading, it will position itself correctly relative to the marker's plane. Once the reading is completed, the user is prompted to proceed to the next marker. Route completion. To finish the route, the user must return the robot to the same marker where the route began. Additionally, the application interface will indicate that the route has been completed. The user can choose to save or discard the recorded route with a confirmation prompt for their selection. As mentioned earlier, routes must start and end at the same position, allowing the robot to establish a circular route through markers. This feature enables continuous autonomous operation during nighttime.
The application serves as the primary interface for accessing and monitoring the status of the robots, and it also is responsible for sending notification in case of abnormal events. To facilitate effective communication with the robots, we will adopt an online database, for example, Firebase. This means that the robot will send its information to the database using the Wi-Fi provided by the shopping mall. Subsequently, the application retrieves relevant information directly from the database, providing a real-time interface. As previously mentioned in the operation definition section, the robot goes through a configuration step before it can be used. During the configuration phase, there will be moments for when the user will want to scan an Aruco marker, and that's when the user will need to click on the Read Aruco tag. Once this configuration is complete, the route will be available on the main screen to initiate it. And after starting the route, the robot's status will indicate how many of the Aruco markers it has read. When any sensor detects something abnormal, the application will send a push notification to the user, as well as update the robot's status with more details about the alert. The physical structure will be composed of the following items: the bladder, the camera above the bladder, a wooden case to position above the bladder to protect the electronic components, and some details about this wooden case. Above this case, there will also be a hollow wooden structure to elevate the camera's height while keeping it connected to the circuit in such a way that it can rotate fully without being obstructed by the robot's main structure. So in solution flow chart, we have the app and the card that will be sending the input to the app that will connect to the Raspberry Pi by Wi-Fi and HTTP requests. Our project will have two main supplies. All the sensors should be connected to the Raspberry Pi. The power bank will connect the Raspberry Pi, and the supply will connect the motor module. For the scope definition, we have the operating hours. There will be a maximum of 7 consecutive hours of operation. The operating environment. The robot's operating environment would be focused on public access areas in shopping malls. The operation is limited to a single floor, and the robot will not design stairs or use elevators. Environmental conditions. It is the responsibility of the shopping mall and its employees to clean the area where the robot will navigate before the robot's operating period. Small objects such as keys and wallets, liquids and food should not be left on the floor in the robot's path. The presence of absence of light will not affect the robot's operation. There should be no people, animals, or machinery moving within the environment. All entities within the environment except the robot must remain stationary. Otherwise, the intruder alarm will be triggered. Operation area size. The maximum distance covered in one round by the robot is 500 meters. It must be taken into account that the robot's camera can detect movements up to 10 meters in the following directions. Distance between Aruco markers. Aruco markers should be positioned at the height of the robot's camera for proper functionality. The maximum distance between two consecutive Aruco markers is 10 meters to ensure the robot's functionality. It is important to note that this distance is not simply the direct distance between the two Aruco markers, rather, the path the robot needs to take to move from one Aruco marker to the next. The first Aruco marker should also be the last one, closing the robot's path. For the budget, we have around 1,000 reais and 200, and thanks.